All right, so if you're listening to this deep dive, then you're probably getting ready for a thermal engineer interview.
And it's a great field to be in right now.
Yeah, for sure. It really is. We're going to be using some awesome resources from RoleCatcher today.
Their career guide, interview guide,
Right, and their AI platform.
it can really help you get that advantage.
So let's dive in. The career guide has this what they do section.
It's really the core of what a thermal engineer is.
Yeah, it lays it all out, talks about thermodynamics and heat transfer
Moving that energy.
through liquids and gases, right?
You got it.
And making sure the systems work in the real world.
Absolutely. From small residential to huge industrial processes.
So picture this. You're in the interview and they ask, tell me about your experience with thermal analysis software.
They're definitely checking your technical skills there.
So it's more than just knowing the software.
Oh, yeah, for sure. They want to know if you've used it on real projects, complex stuff.
How do you get that across?
You got to think about specific times you used it to solve a problem.
So like, give them an example.
Exactly. Like maybe you modeled heat transfer for a complex system.
Or had to analyze the performance of a heat exchanger.
Exactly. And you got to quantify it.
How do you mean?
So instead of just saying you've used ANSYS, tell them, I've used ANSYS for 3 years to model heat transfer in electronic components.
Makes sense. That shows a lot more than just a name drop.
And this is where RoleCatcher's AI can help you.
Oh, right. Their CV builder thing.
Yep, it actually scans job descriptions.
And tells you what skills they're looking for.
Exactly.
Nice. Okay, next question. How do you determine the right thermal insulation for a job?
Now they're testing your thought process.
Seems like a simple question, but there's a lot there.
Yeah, they want to see how you think it through.
Like your analytical skills.
You got it. They want to know that you're thinking about the temperature range.
The thermal conductivity, right?
How easily heat passes through it.
Yeah.
And even moisture resistance, fire resistance.
So how do you answer something like that?
Real-world examples are your friend.
Give us one.
Let's say you were designing insulation for a refrigeration unit.
Okay, I'm with you.
You could say you thought about the temperature difference inside and out.
And that affects the type of insulation you choose?
Right. You also have to think about the conductivity of different materials.
And if there might be condensation?
That's the kind of thinking they want to hear.
That's good. It makes it more real.
Exactly.
Okay, here's a question that seems straightforward. Can you explain the difference between conduction, convection, and radiation heat transfer?
You always get that one.
But how do you make your answer stand out?
It's all about explaining it simply and clearly, right?
No jargon.
Well, you can use jargon, but explain it.
Right. Make sure they understand.
And think of good examples they can relate to.
So how would you explain conduction?
Imagine holding a metal spoon over a flame.
The heat going up the handle.
That's conduction.
Ah, I get it.
For convection, think of a pot of boiling water, the heat moving through the water,
And
the
radiation.
warmth you feel from the sun.
Nice. Those are good examples. Everyone knows those things.
It makes it easy to understand.
Okay, so what if they follow up with, like, great examples. Now tell me about a time you used these types of heat transfer in a project.
That's when you really show off what you've done.
So you could talk about a project with a heat exchanger.
Exactly. And how you considered all 3 types of heat transfer while designing it.
And I bet RoleCatcher's AI could help here too.
Their interview feedback tool can make your answers even better.
Like it tells you what to improve.
Yep. Make sure you're hitting all the right points.
Cool, it's like having a secret weapon. Okay, next question. Can you describe your experience with thermal testing and validation?
This is where you show that your designs actually work.
So it's about real-world results, not just theory.
Exactly. You're proving that your design can move from an idea to a product that works.
So what do you talk about?
The methods you've used, temperature sensors, stress tests.
And did you simulate extreme conditions?
Exactly. The more detail you give, the better.
It's good to have a success story, too.
A real-world example always helps.
When is yours?
Well, I was working on a cooling system for a high-performance server once.
This sounds intense.
During testing, we found a tiny flaw that caused overheating.
Oh.
Yeah, but we used the test data to tweak the design, and the final product worked perfectly.
That's a great example.
It shows why testing is so important. It can make or break your design.
Okay, let's move on to a question that ties thermal engineering to electronics. Can you explain the impact of thermal management on the performance of electronic systems?
This is a big one, especially these days with everything getting smaller and more powerful.
Right, it's not just about things melting down anymore.
Yeah, even a little heat can affect performance, cause errors, shorten the lifespan.
So how do you explain all that?
You focus on the real-world effects.
Okay, give me an example.
Yeah. Good thermal management stops overheating, reduces wear and tear, improves energy efficiency.
And the device lasts longer.
Exactly. You can use a project you worked on as an example.
Like a cooling system for a computer processor.
Perfect. Explain how it kept the temperature right where it needed to be, stopped performance from dropping, made it more reliable.
I like that. Very concrete.
And RoleCatcher's AI can help you pick the right examples for the job.
That's awesome. It's like it's tailoring your answers for you.
It really is.
Okay, before we move on, let's talk about something that's super important. Understanding the career path.
You gotta know how things change as you gain experience.
The career guide has a section on that, right?
Yep, career stages it's called.
So like an entry-level thermal engineer,
They're usually assisting senior engineers, doing more basic tasks.
but then you move up to junior or mid-level.
You start designing systems, overseeing things.
And senior level.
You're leading complex projects, mentoring other engineers, pushing the boundaries.
So knowing where you are in that path helps you answer questions,
It really does.
especially if you're aiming for a certain level of seniority.
And RoleCatcher's AI can analyze job descriptions and suggest skills to emphasize.
Based on your career stage.
Right. It's all about showing them you're the right fit.
This has been really helpful, but we've got more to cover. We'll be back in a flash to dive into more questions and expert advice.
All right, we're back and ready to tackle some more questions to help you ace that interview.
Let's do it. What about this one? How do you ensure thermal stability in a mechanical system?
That's a good one. It really gets at your problem-solving skills.
So what are they looking for with that question?
They want to know you understand how heat affects those systems and how to keep things running smoothly.
Like, what are the key things to think about when answering?
Well, first off, material selection is huge. Different materials react differently to temperature changes.
Right. Some expand more than others.
Exactly. You got to choose materials that can handle the heat without falling apart.
So like using materials with low thermal expansion coefficients would be a good example.
Spot on.
Yeah.
Especially in high temperature situations.
Makes sense. So what else?
Design is key too. Sometimes you need to build in features that allow for expansion and contraction.
Oh, I see. Like those expansion joints you see on bridges.
That's a great example. Or flexible couplings, things like that.
And what about thermal barriers?
Those are essential. They protect components that are sensitive to heat or need to stay at a specific temperature.
It's like giving them a little safe space from the heat.
Exactly. Think about heat shields on spacecraft or insulation around electronics.
Good point. So you've got materials design, and then what?
Don't forget testing. You always got to validate your design, make sure it actually achieves that thermal stability.
Right, back to the real-world results.
Always. Give them a real-world example that ties it all together.
Okay, like what?
Imagine designing a gearbox for a wind turbine.
Oh, yeah. Those things are out in all kinds of weather.
Exactly. Scorching sun, freezing cold, big temperature swings.
Tough environment.
You'd need materials that can handle those extremes, include design features to manage expansion and contraction.
And use those thermal barriers to protect the sensitive parts.
Exactly. And then you test it rigorously to make sure it all works as planned.
I like it. A very practical example.
That's what they want to hear.
Okay, let's shift gears a bit. Can you explain the role of heat exchangers in thermal engineering?
Heat exchangers are everywhere. They're the unsung heroes of a lot of systems.
What do they do exactly?
They let heat move between two fluids without them actually mixing.
So no direct contact.
Nope. Think of the radiator in your car.
Okay, I see where you're going with this.
It uses a heat exchanger to transfer heat from the engine coolant to the air flowing through the radiator.
That's a good one. Everyone's seen a radiator.
So, what should people focus on when answering this question?
What are the key points?
Knowing the different types of heat exchangers and how they're used.
And the things that affect their performance.
Exactly. Flow rates, temperature differences, thermal properties of the materials.
Sounds like a lot to remember.
It's all about understanding those fundamentals.
And having a project to talk about where you actually designed or analyzed a heat exchanger would help, right?
Absolutely. Tell them about a time you optimized a heat exchanger to improve efficiency or save money.
A real-world win.
And guess what? RoleCatcher's AI can help you here too.
No way, really?
Yeah, their AI can actually analyze job descriptions.
Get out. What does it do?
It suggests which types of heat exchangers to focus on based on the industry or the job.
That's amazing. It's like it's doing your homework for you.
In a way, it is. It takes the guesswork out of it.
I love it. Okay, next question. Can you explain the impact of thermal management on the performance of electronic systems?
This one's crucial, especially now that electronics are getting more and more compact.
It's more than just stopping them from bursting into flames, huh?
Even a little bit of extra heat can make things run slower, cause errors, make them wear out faster.
So how do you explain that in a way that makes sense?
Talk about the real-world consequences.
Give me an example.
Say you designed a cooling system for a high-performance computer processor.
Or a smartphone.
Perfect examples. You'd explain how your design kept it cool, prevented slowdowns, ensured it would last longer.
Makes it very real, very tangible.
Exactly. And again, RoleCatcher's AI can help you pick the best examples for the specific job you're going for.
Okay, this one might be a bit technical. How do you calculate the heat transfer coefficient for a given application?
The heat transfer coefficient, the heart of thermal engineering.
So what are they really getting at with this question?
They want to see if you understand the fundamentals and can apply them.
So how would you approach this one?
I'd start by explaining that the heat transfer coefficient depends on several things.
Like what?
The type of heat transfer, conduction, convection, or radiation, the properties of the materials, the shape of the system, the flow conditions.
Sounds complicated.
It can be. But with a good example, you can make it clear.
So what's your go-to example?
Calculating the heat transfer coefficient for a pipe carrying hot water or a heat sink on an electronic component.
Okay, I can see that.
You walk them through the steps, point out the important variables, and the equations you'd use.
Is there a way to really impress them with this one?
You could mention that there are specific correlations and formulas used in different situations.
Showing off your advanced knowledge.
Exactly. It shows you really know your stuff.
And RoleCatcher's AI can help you practice your answer.
Absolutely. It'll give you personalized tips to make your answer even better.
Okay, before we wrap up this section, I want to emphasize something we talked about before. Continuous learning.
The field's always changing, gotta stay on top of things.
The career guide talks about that too, right?
Yeah, the knowledge and learning section.
They recommend subscribing to industry magazines, going to conferences.
And even getting advanced degrees or certifications.
So never stop learning.
Exactly. Joining professional groups like ASME or ASHRA can be really helpful too.
Those are the big ones, right?
They offer great networking, and you can stay up to date on what's happening in the industry.
And there's a ton of stuff online too.
Oh yeah, websites, blogs, forums, you name it.
So when they ask about your commitment to learning, you'll have lots to talk about.
It shows them you're passionate and want to keep growing.
Speaking of growth, the career guide also talks about different paths for advancement.
It's good to know where you can go in this field.
So you start with entry-level positions, get some experience, build your skills.
Then you move into junior, and mid-level roles take on more responsibility.
And maybe even lead some projects.
Exactly. And then at the senior level, you're leading those complex projects, mentoring others, really shaping the future of the field.
It's pretty cool.
It is. And it's important to think about where you are in your journey and how your experience fits with the job you want.
Makes sense. And don't be afraid to ask about career development during the interview.
Absolutely. It shows you're thinking long-term.
We've covered so much today, but we're not done yet. We'll be back in a flash for the final part of our deep dive.
Welcome back for the final part of our thermal engineer interview prep.
I'm excited to finish strong.
Yeah.
What about this question? Can you describe your experience with thermal modeling and simulation?
This is where you really get to show off your technical skills.
So it's about more than just knowing the software.
Oh yeah, they want to know you understand the why behind it.
Like you can build those virtual models and use them to predict how things will work.
Exactly. Identify problems before they happen, even optimize designs before you build anything.
So what kind of things should you talk about?
Your experience with specific software like ANSYS or COMSOL.
Name dropping the big players.
It helps. And talk about the types of models you've created.
Like what kinds of systems have you simulated?
Have you modeled the heat transfer in an engine or the airflow in a data center?
Given those real-world examples.
Always. A good story can really make your experience come alive.
What's one of yours?
I was working on a project to optimize a heat sink for a new graphics card.
Okay, those things can get hot.
Yeah, and our initial design wasn't good enough.
Even with all the calculations.
Yeah, but through thermal modeling, we found out the heat sink wasn't doing its job.
So the model showed you the problem.
Exactly. We were able to tweak the design in the model, change the shape and the airflow, and came up with a solution that kept the GPU nice and cool.
That's awesome. It shows how powerful modeling can be.
It can save you a lot of headaches down the line.
And this is where RoleCatcher's AI feedback can come in handy, right?
Absolutely. It can help you focus on the most relevant parts of your experience.
So you're presenting your skills in the best possible light.
Exactly. You're showing them why you're the right person for the job.
Okay, before we wrap up this episode, I want to circle back to RoleCatcher's AI.
It's such a valuable tool for anyone preparing for an interview.
It's like having a secret weapon.
I like that analogy.
So let's recap how it can help. First, their CV Builder analyzes job descriptions and pulls out those keywords and skills that employers are looking for.
It helps you tailor your resume to each specific job.
Second, their interview guide provides feedback on your answers,
It helps you create clear, impactful responses.
like a personal coach.
Exactly.
And finally, they offer video practice with AI feedback.
So you can practice your delivery and get feedback on your body language and tone.
It's all about presenting yourself confidently and professionally.
It really is.
So if you're serious about acing that thermal engineer interview, check out RoleCatcher and all their amazing resources.
You can make all the difference.
And as we close out this deep dive, I want to leave you with a question to think about.
I like to end on a thought-provoking note.
As technology advances, what emerging trends in thermal engineering excite you the most?
And how do you see yourself contributing to those advancements?
Thinking about the future of the field shows that you're not just looking for a job, but you're looking to make a real impact.
That's what it's all about.
We hope this deep dive has given you the knowledge and the confidence to succeed in your thermal engineer interview. Remember, preparation is key, and with the right resources and a positive attitude, you can achieve anything. Good luck.